Okay, so we are going to talk about logarithms today. Sorry I couldn't be here for this. It's an exciting day. Um, just in case you forgot what I look like, well, I guess that's not really what I look like, but there you go. All right, so take a minute, pause the video, talk with your neighbors, just jot down the answers to these questions, and then we'll come back to the video in a second. So we're basically looking for the exponents. So we're looking for those missing powers. As it says, don't use your calculator, and try and use the properties of exponents to figure those things out. So I'll give you a second, pause the video, and then work on these problems. Okay, hopefully that went well. And so now we're looking for those exponents. First one hopefully is pretty easy. We're just looking for a power of 2 that is 8. And so 2 times 2 times 2, so the power is 3. Remember that property of exponents for the next one. Anything to the 0 power will be 1. Next one's a little trickier. We need to take the square root of 4 to get 2, and the power that takes the square root is 1/2. Next one, if you think of that 0.5 as 1/2, to turn 1/2 into 4, you're going to need to do a couple things. You're going to need to square that 2 in the denominator and then flip it over. And the way exponents flip things over, take the reciprocals with a negative sign. So this is going to be to the -2 power. And then the last one, we need to take the square root to go from 16 to 4, and then we also need to take the reciprocal. So those two things together give us an exponent of -1/2. So as you hopefully remember from Algebra 2, exponents are closely related to logarithms, and basically logarithms are what you use when you're looking for an exponent. So logarithms are basically the problems that we just did. It's just a new notation for them, and here's that new way to write them. And so when we say log base 2 of 8, we're basically saying this over here on the left hand side. We're saying find a power of 2 that equals 8, and so the power of 2 that equals 8 is 3. So notice all these answers over here are just the exponents. So when you evaluate a logarithm, you're looking for an exponent. So down here, log base 0.5 of 4, we're looking for the exponent of 0.5 that gives me an answer of 4, right? And we had already answered that question. It was -2. And so here's sort of what is going on in general. When we have log base b of x, we're first of all going to assume that the base is greater than 0, and we're saying what is the exponent? What is the power I should raise b to in order to get x as my answer? So written out algebraically, this thing in red here is sort of the key, right? These two equations are equivalent, and you need to sort of understand how to switch back and forth between the two of those. So log base b of x equals y. That means I'm looking for a power of b that equals x. Y is the power, right? The log equals the power. So this is saying b to the y equals x. And so the base of the log becomes the base of the exponent, right? And so we'll practice switching back and forth between these two things a lot. Here are just a couple examples of equivalent equations, so make sure these make sense to you. Log base 3 of 9 equals 2. That's saying 3 to the second power equals 9. Log base 8 of 2 is saying what power of 8 equals 2. Well, we need to take the third root, and so the third root of 8 is written as an exponent as 1/3. Log base b of 1 equals 0 because b to the 0 equals 1. And then here we take a reciprocal, so 10 to the -2 equals 0.01. Finally, just a reminder that your calculator does not have, well, I guess different calculators have different buttons now, but the most common bases for logarithms are base E and base 10, and those are the buttons you should definitely see on your calculator. ln is for the natural log, which is base E, and then the common log is just log, which is base 10, and some calculators may let you type in any base you want also. Even if your calculator doesn't allow you to do that directly, we'll learn something called the change of base formula, and we'll talk about that in the next day or two. Thank you. Hope you're having a good day.